Hi students, good morning. Welcome to Kamal YouTube channel. And in this video I am going to explain an important part of hydrogen and its compounds, that is volume strength. So volume strength of hydrogen peroxide. Okay, what is mean by volume strength? Volume strength means the volume of oxygen released by decomposition of one volume hydrogen peroxide is called volume strength. What? The volume of oxygen released by the decomposition of one volume hydrogen peroxide is called what? Volume strength. Okay, so let me write the definition. Volume of oxygen released by the decomposition of one volume H2O2 is called a volume strength. So hydrogen peroxide decomposes into water and oxygen. What? Water and oxygen. The hydrogen peroxide split into water and oxygen. What? Water and oxygen. The volume of oxygen released by the decomposition of one volume hydrogen peroxide is called what? Volume strength. Okay. So suppose X volume of hydrogen peroxide means what? X volume H2O2 means what? It means at normal temperature and pressure, at NTP, 1 liter of hydrogen peroxide will give X liters of oxygen. So X volume H2O2 means what? At NTP, 1 liter of H2O2 will give X liter of oxygen. What? X liter of oxygen. Or 1 milliliters of H2O2 will give X milliliters of oxygen. What? X milliliters of oxygen. So this is a simple mean of volume strength. For example, 10 volume H2O2 means what? 10 volume H2O2 means what? It means at NTP, 1 liter of hydrogen peroxide will give 10 liters of oxygen. At NTP, 1 liter of H2O2 will give 10 liters of oxygen. What? 10 liters of oxygen. Or 1 milliliter of H2O2. 1 milliliter of H2O2 will give 10 milliliters of oxygen. What? 10 milliliters of oxygen. So similarly, 20 volume H2O2 means what? 20 volume H2O2 means what? 20 volume H2O2 means what? It means 1 liter hydrogen peroxide will give 20 liters of oxygen, or 1 milliliters of H2O2 will give 20 milliliters of oxygen. So this is a simple mean of volume strength. Okay, what is volume strength? Volume of oxygen released by the decomposition of one volume hydrogen peroxide is called what? Volume strength. Okay, now the concentration of the hydrogen peroxide is calculated by using volume strength. Okay, so now the hydrogen peroxide, that is H2O2, is split into water and oxygen. Okay, hydrogen peroxide is decomposes into water and oxygen. Now here 2 H2O2 and 2 H2O. It is a stoichiometric equation or balanced equation of decomposition of hydrogen peroxide. In the balanced equation, 2 moles of hydrogen peroxide decomposes into 2 moles of water and 1 mole of oxygen. That means 2 moles of hydrogen peroxide decomposes to release how many moles of oxygen? 1 mole of oxygen. Is it clear? So 2 moles means 2 into 34 grams. Okay, so 1 mole H2O2 mass is what, Nana? 34 grams. Here how many moles of hydrogen peroxide decomposes over here? 2 moles. So 2 into 34 grams of hydrogen peroxide decomposes, it will give 1 mole oxygen. 1 mole oxygen. At STP conditions, 1 mole gas occupies 22.4 liters of volume. Is it clear? 1 mole any gas occupies how much volume? 22.4 liters of volume. Okay. So here 68 grams of H2O2 will give how many liters of oxygen? 22.4 liters of oxygen at STP conditions. Is it clear? That is what? 22.4 liters of oxygen released from how many grams? 68 grams of H2O2. Is it clear now? So here 22.4 liters of oxygen released from 68 grams of hydrogen peroxide. So V liters of oxygen released from how many grams of H2O2. Okay, so this is called what? It is volume strength. Volume strength. Okay, here where V means what? Volume strength. So it is the volume of oxygen released by the decomposition of 1 volume H2O2 is called what? Volume strength. Okay, now here 22.4 liters of oxygen released from 68 grams of H2O2 and V liters of oxygen are released from how many grams of H2O2. Okay, now cross multiplied. Then what happened over here? So 68 into V upon 22.4. Okay, now 4 17s are 68 and 4 5.6 are 22.4. So that is equals to what? 17 V upon 5.6. This is called strength of hydrogen peroxide. It is strength of hydrogen peroxide. Okay, now you know what is normality? Normality equals to strength upon gram equivalent weight. Strength upon gram equivalent weight. So what is the gram equivalent weight of H2O2? Now gram equivalent weight of H2O2 equals to what, Nana? Gram molecular weight upon N factor. What is N factor? What is N factor? What is N factor? So N factor is, let me explain. Hydrogen peroxide H2O2 can act as an oxidizing agent as well as reducing agent in both acidic and basic medium. Okay, suppose H2O2 in presence of acidic medium, it gains 2 electrons to give 2H2O. Okay, so this is a reduction of H2O2. Here it is a reduction reaction. Here hydrogen peroxide undergoes a reduction reaction because where oxygen oxidation number is -1, where oxygen oxidation number in H2O is -2. It converts from -1 to -2 oxidation state. What happens over here? Yes, oxidation number is decreases. Yes, decrease in the oxidation number is called what? Reduction. Or the H2O2 gains electrons. Gain of electrons is also called as what? Reduction. So hydrogen peroxide itself reduce means it oxidizes others. It oxidizes other species, hence so it is oxidizing agent. Hydrogen peroxide is oxidizing agent in acidic medium. So how many electrons are involved over here? 2 electrons are involved. So N factor is 2. So N factor of hydrogen peroxide is what? 2. Okay, I hope you understand. Now the students, the gram equivalent weight of hydrogen peroxide is equals to what? Gram molecular weight upon N factor. So gram molecular weight of H2O2 is what? 34 upon N factor is 2. That means the 2 electrons are involved in oxidizing or reducing reactions to give 17. that is equals to what? 17. So gram equivalent weight of hydrogen peroxide is what? 17. So let me erase this one. Now the normality equals to strength is what, Nana? 17V upon 5.6 into 1 upon 17. Gram equivalent weight is 17, and where 17 gets cancelled, then normality equals to volume strength upon 5.6. so this is a very important formula. Just you have to remember this formula. You need to remember this formula for the calculation of normality of hydrogen peroxide solution whenever volume strength will be given. So okay, what? Normality equals to volume strength upon 5.6. Okay, now what is the relation between molarity and volume strength? You know the relationship between molarity and normality. What is the relationship between molarity and normality? Yes, normality equals to molarity into n factor. Okay, so normality equals to molarity into n factor. So normality equals to molarity into n factor. So normality equals to what now? Volume strength upon 5.6. Volume strength upon 5.6 equals to molarity into n factor of hydrogen peroxide is 2. Now molarity equals to what? Volume strength upon 11.2. So this is the relationship between molarity and volume strength. Okay, so we can calculate the molarity of hydrogen peroxide solution whenever the volume strength of that solution will be given. So which formula is used now? So molarity equals to volume strength upon 11.2. So you have to remember these two formulas to calculate the molarity and normality of hydrogen peroxide solution whenever the volume strength will be given. Okay, so what is the relation between normality and volume strength? Normality equals to volume strength upon 5.6. What is the relation between molarity and volume strength? Molarity equals to volume strength upon 11.2. Okay, so now let me explain few important numericals based on the volume strength. Just you keep in your mind the formulas. That is what? Molarity equals to volume strength upon 11.2 and normality equals to volume strength upon 5.6. Just you have to remember these two formulas to calculate the concentration of hydrogen peroxide solution whenever volume strength of H2O2 will be given. Okay, these two formulas are very important. Okay, just you must be remember these two formulas. Okay, so that is molarity equals to volume strength upon 11.2, normality equals to volume strength upon 5.6. Now let me explain few important numericals based on volume strength. Okay, so now find out the molarity and normality of 1.12 volume H2O2 solution. This is an important numerical. What? Find out the molarity and normality of 1.12 volume H2O2 solution. Here volume strength is given, that is 1.12. We have to calculate molarity and normality of that solution. Okay, so what is the molarity? Molarity equals to volume strength upon 11.2. So volume strength is given how much? 1.12. So 1.12 upon 11.2, that is equals to 0.1 m. So this is the molarity of that solution. Okay, now the normality equals to what? Volume strength upon 5.6. Okay, so volume strength is given, that is 1.12 upon 5.6, that is equals to what? 0.2 n normality. So this is the normality of 1.12 volume H2O2 solution. I hope it is clear. Okay, now let's move on to the next numerical. Calculate the volume strength. Calculate the volume strength of calculate the volume strength of 1.5 normality H2O2 solution. Calculate the volume strength of 1.5 N H2O2 solution. Here normality is given. We need to calculate volume strength of that solution. We know the relation between volume strength and normality. What? Normality equals to volume strength upon 5.6. Okay, so now here normality is given, we have to calculate volume strength. Now rearrange this formula. What? Volume strength is equals to normality into 5.6. Is it clear? So normality equals given, that is how much? 1.5 into 5.6, that is equals to what? 8.4. This is the volume strength of that solution. I hope you understand. Is it clear or not? Yes, it is very simple as well, and it is also very important as well. Okay, now let's move on to the another numerical. Now density of hydrogen peroxide solution can also be calculated by using volume strength. How to calculate the density of hydrogen peroxide solution by using volume strength? Now let me explain one example. Calculate the density. Calculate the density of 10 volume hydrogen peroxide solution. Calculate the density of 10 volume H2O2 solution. Here volume strength is given, so we have to calculate the density of that solution. You know what is molarity? So molarity can be defined as the number of moles of solute present in 1 liter of solution is called molarity. Already we have learned. Okay, what? Molarity equals to number of moles upon volume in liters. Okay, so what is the number of moles? How to calculate the number of moles? So yes, weight by gram molecular weight. So when number of moles equals to weight by gram molecular weight, and this is substituted over here. M equals to weight upon gram molecular weight into 1 upon V in liter. Okay, so we know what is density. Density equals to what? No, mass by volume. Yes or no? Yes, weight by volume or mass by volume. So this is said to be density. Weight by volume is called what? Density. So molarity equals to density upon gram molecular weight. So density equals to what? So yes, molarity equals to what? Density upon gram molecular weight. Okay, so now we have to calculate the density of that solution. So molarity. So now density equals to what? No, density equals to molarity into gram molecular weight. Yes, is it clear? So density equals to what? No, molarity into gram molecular weight. So molarity is not given. Here volume strength is given. We know the relation between molarity and volume strength. Yes, molarity equals to volume strength upon 11.2. Okay, so now density equals to volume strength upon 11.2 into gram molecular weight. Is it clear? Yes, now we can calculate density. So where V is volume strength is given, that is how much? Yes, 10 volume. And we know gram molecular weight of H2O2, that is what? 34. Yes. So density equals to volume strength is 10 upon 11.2 into gram molecular weight of hydrogen peroxide is what? 34. So that is equals to 30.35. This is the density of that solution. I hope you understand. Okay. Okay. Did you understand? I hope it is clear, and it is a very important and very easy concept. Okay, so volume strength. What is volume strength? It is the volume of oxygen released by decomposition of one volume hydrogen peroxide is called volume strength. So these two formulas, just you need to remember these two formulas to calculate molarity and normality of hydrogen peroxide solution whenever the volume strength of H2O2 will be given. Okay, just you need to remember these two formulas, and you can solve any numerical based on volume strength. Okay, I hope you it is clear, and thanks for watching this video. Thank you very much.